Right, so welcome to our last lesson on congruent triangles. In your GCSE or IGCSE maths exam, they're going to give you two triangles like the ones I have here, and they're going to ask you to prove that they are congruent or not. Okay. In the first two lessons of congruency, we've been looking at how to tell whether two triangles are congruent or not. So I would like you to pause the video and try question one and then question two. So pause the video, try question one and question two. Okay, so hope you tried the questions. Question one says, show that the two triangles below are congruent. Now, this triangle, for it to be congruent to this, it means that it must be exactly the same size. I can see there's this 4 centimeters, and there's that 4 centimeters there. I can see there's this 3 centimeters here, and there is a missing side here. So I'm assuming that could be 3 as well. I can see there's 5 here, and there's 5 there. Okay, so how do we prove this? You need to think about the 4 conditions for congruency. The first one is that if you have a right angle triangle like this, then number one is that you of course have the right angle triangle. So the R, that's right angle. You also need to have hypotenuse being the same. And then you also need to have any side being the same. So right angle triangle, let's check that. This one has got right angle triangle there. And this one has got also right angle triangle. So the first condition has been met. You can check that. The other one is now to find if hypotenuse are the same. Remember, for a right angle triangle, hypotenuse is the long side. So that's that one there and this one here. So for this, the hypotenuse is 5. We know that. We're going to check if this one is going to be 5. Now, to find the hypotenuse, we can call it C. And we're going to use Pythagoras theorem, which is C squared equals to A squared plus B squared. Okay. Now, the C squared is the hypotenuse you're looking for. A squared is 3, which can be the base, and then B can be that. So we have 3 squared, and we add 4 squared. Okay. If we do that, C squared is going to be 25. Okay. That's going to be 9 plus 16, which is 25. And to find C, use square root. So square root of 25 is going to be 5 centimeters. Okay. So this C here, which is the hypotenuse, is basically 5 centimeters. Okay. That's what's in there. So we can see that the hypotenuse, which is the longest side, which is the side opposite the right angle triangle, is the same as that hypotenuse there, which is the longest side and is opposite the right angle triangle, right? So hypotenuse has been met. Now the other thing we're going to need to do is to look for any other side that could be equal. Apart from hypotenuse, is there any other side that that are equal in length? Okay. Now we have 5 here and we have 4 there. Now I can see this 4 here has got another 4 there. So therefore, I've got sides that are the same. They don't have to be corresponding. For a right angle triangle, it just works. Okay. As long as the hypotenuse and the right angle triangle is there, just pick any other side that would match. So this 4 is matching that. Therefore, this condition is met. Okay. Now, if you want, you can use Pythagoras theorem on this one. You do 5 squared, take away 4 squared, then square root. The answer is going to be 3 centimeters. Okay. So you can see that even if you're to get that, then this one is still the same as that side anyway. Okay, so that's that. Question 2. ABCD is a parallelogram. Right, so I've got parallelogram here. Prove that the triangles ABC and ADC are congruent. So the triangle ABC, so this triangle here, is congruent to triangle ADC. So this triangle here. Okay, so this is the triangle we're talking about. You can see that's triangle A if you want, and that's triangle B if you want. Okay, so they are congruent. Now, how are you going to prove that? Now, remember the first thing you need to think about is to look at the corresponding sides and see whether they're equal or not. Look at angles and see whether they're equal or not. Okay, so the first thing I can see is that when it comes to parallelogram, the angles that are opposite to each other, so that angle there and that angle there will always be equal in a parallelogram. It works like that. So angle B is equals to angle D. We don't just say angle B, we say angle ABC. B is the angle, so it's angle ABC is equals to, so this angle B here, which is called angle ABC. So this angle here is the same as angle D. Angle D is the same as angle ADC. Okay, so it's ADC. So these angles are equal. That's the first thing. So I have the first rule being A. I've got one A that is equal, one angle. That's the first rule, so A. The other thing I know is that I know that they are sharing this side. See, this AC belongs to this triangle, and AC belongs to that triangle as well. So we got a side that is the same. So that's going to be S then. Okay. So we say that AC on the first diagram is the same as AC for the second diagram. They are sharing it. So that is a side that is the same. Okay. Now, what else can we say that is the same here? There are so many other things that you can see that is the same here. If this angle is the same here, and notice that this side is the same as that side. Okay. Now, what that means is that this angle here is going to be the same as this angle here. Yeah, alternate angle theory. So if you think about the alternate angles, if I have that, then this angle here will always be equal to that angle there, as long as these two lines are parallel to each other. So this angle here, so that's this here is the line in the middle, right? And if you look at this one, this is basically the Z if you want. So that's basically the Z if you want, right? So this angle here alternates with that angle there. So therefore they are equal, alternate angles. So you can say that this angle is also equal. So I've got another angle that is the same there. Now the other thing that I also have the same, I also got this other angle that's the same. So this angle here is the same as that angle there because they're alternate. So this angle is alternate to that. So now I have another angle. Okay. So even there I can just stop. I've got enough. So I've got two angles that are the same, AA, and I've got one side that's the same. That's just enough. So remember there was a rule which says AAS. So any two angles and corresponding sides are equal. So I've got this angle, if you want, is the same as that angle. And I've got this angle here, the same as that angle. Right? So that's AA. And I've also got corresponding sides the same. I've got AC corresponding to AC because they share that. Or if you want, AD is equal to BC. Or DC is equals to AB. So many things you can talk about here. Okay. The other thing you can say is that the three sides are equal. Yeah. So the three sides are basically just equal. How do I know that? So DC is equals to AB on that one. That's one side equal. AD is equals to BC on that one. So that's another side. And then AC is equals to AC. So SSS is another thing you can say. So SSS is something else you can say. Okay. So there's so many things you can do with this kind of questions. So many answers you can give. Right. So I would like you to pause the video and look at the explanations in the answers very carefully. So look at the explanations in the answers very carefully and just mark your answer. Okay, I hope you got that. Now I would like you now to try question. I would like you to try question 3 and 4 very quickly by yourself. So try question 3 and 4 very quickly by yourself. Right, so hope you tried them. I'm just gonna do question 3 for you only because of time. Now, so ABCD is a regular pentagon. Regular pentagon will mean that number one, the sides are equal. So this side is equal to that side, is equal to that side, equals that side, equals that side. That's the first thing. You see? The other thing is that the angles are the same. So the angles, that angle will be the same as that. The whole of that is equals the whole of that is equals to that is equals to the whole of that is equal to the whole of that. Okay, so the angles are also just basically equal. Right. So that part is just equal. So the parts I'm coloring up are basically just equal. So the 5 angles in a pentagon are equal. So that's the first thing I need you to understand. Now, how do we prove that triangle ABC, so triangle ABC and CDE and CDE are congruent? So many things you can say here. Number one, you got the angle. So this angle, angle B equals to angle D. Okay, so angle ABC is equals to angle EDC or CDE. So these angles are equal. That's the first thing. The other thing, you have these two sides that make the map equal, isn't it? Because in a regular pentagon, the sides are equal. So you can say that the angle between the two sides are equal. Okay, so this angle and this side and that side correspond to those two sides, and they're just basically equal. So the rule is SAS, and there's other rules as well. Okay, so if you just want to pause the video quickly and then try and then mark your answer now. pause the video and mark your answer quickly. Okay, hope you've done well on that, and thank you.